SpaceX can land 100 tons of cargo on the moon. That is more than any vehicle in history, more than the entire Apollo program delivered across all 6 landings. And with a launch window roughly every 10 days, they could send one vehicle after another, stacking hardware on the surface faster than any space program has ever operated. But here's the part that nobody talks about. Once that cargo touches down, there's nothing to plug it into. No power grid, no oxygen pipeline, no foundation, no floor. Just regolith, fine abrasive dust that clings to everything, and radiation. In 2019, China's Chang'e 4 lander measured it directly on the surface, about 1,370 microsieverts per day. That is roughly the same dose as a full-body CT scan, every 2 weeks, with no way to turn it off. Now, most videos about a moon base ask the same question: when will it happen? That is the wrong question. The right question is, what do you actually build when you get there? What does the first wall look like? What machine lays the first floor? And what happens to the human body while all of that is being built? This is the blueprint, system by system. So let us start with the vehicle, the thing that actually gets all of this hardware to the moon. Starship HLS stands roughly 50 meters tall. That is about the height of a 16-story building, and it can deliver up to 100 metric tons of cargo directly to the lunar surface. To put that in perspective, across all 6 Apollo landings, the total scientific equipment and hardware delivered to the surface was roughly 3,000 to 4,000 kilograms. Apollo 17's lunar rover alone weighed about 210 kilograms. Starship carries 100,000 kilograms in a single trip. That is not an upgrade. That is a completely different category of logistics. Now, here is why the moon changed everything for SpaceX's timeline. Mars has a launch window that opens once every 26 months. Miss it by a week, and you wait 2 more years. The moon? You can launch roughly every 10 days. The transit time is about 2 to 3 days, compared to 6 or 7 months for Mars. So in the time it takes to wait for a single Mars window, you could send approximately 78 starships to the moon. That is not a small advantage. That is a completely different development speed. And for a company that built its entire philosophy on fast iteration, build, break, learn, rebuild, the moon is the perfect testing ground. And the timing is not theoretical. In February 2026, Musk publicly shifted SpaceX's priority, moon before Mars. A self-growing city, he said, in less than 10 years. 1 month later, NASA announced a $20 billion 7-year plan to build a permanent base at the lunar South Pole. Robotic landings first, then habitats, then permanent infrastructure. And in April, Artemis 2 completed a crewed flyby of the moon. So this is not a pitch deck. Hardware is moving. Budgets are allocated. The clock is running. But here is a problem that most people do not think about. Starship HLS is 50 meters tall. The crew cabin sits at the very top, and the lunar surface is at the bottom. That means every time an astronaut needs to step outside, they have to descend roughly 35 meters, about 11 stories, using an elevator built into the side of the vehicle. And NASA's own Office of Inspector General has flagged this elevator as a top risk for the entire program. Think about what that means. You are on the moon. The elevator jams. Lunar dust, which is electrostatically charged and abrasive enough to wear through metal, has gotten into the motor housing. And there is no secondary exit. No ladder that tall would be practical in a pressurized suit. You are trapped, 11 stories above the surface, on the moon. So the delivery system exists, 100 tons, every 10 days, 2 to 3 day transit. That part of the equation is further along than most people realize. But a Starship is a rocket, not a building. The walls are millimeters thin steel, not enough for radiation shielding. The layout is optimized for flight, not for living on a surface. So once the cargo arrives, what do you actually build to live in? And what do you build it from? when the nearest hardware store is 384,000 kilometers away. So why can you not just live inside the Starship? Well, the short answer is radiation. The moon has no atmosphere and no magnetic field. That means every particle from the sun and every cosmic ray from deep space hits the surface directly. On Earth, you absorb roughly 6 to 7 microsieverts per day from natural background radiation. On the moon, according to measurements taken by China's Chang'e 4 lander in 2019, the dose is about 1,370 microsieverts per day. That is roughly 200 times higher, and the steel walls of a Starship, they are only about 4 millimeters thick. That is not a radiation shield. That is a suggestion. Now, for short stays, a week, maybe 2, Starship works as a temporary shelter. It is pressurized, it has life support, you can survive inside it. And in fact, for the first Artemis landing missions, that is exactly the plan. The crew arrives, they live inside the Starship for a few days, they do their work on the surface, and they leave. But if the goal is a city, if people are going to stay for months or years, then you need something that was actually designed to be lived in. And more importantly, you need walls thick enough to stop radiation from slowly destroying your DNA. And this is where it gets interesting. The leading concept right now is a hybrid approach. Import the skin, print the armor. The European Space Agency, working with the architecture firm SOM and MIT, has designed a modular inflatable habitat. It ships compact, folded inside a Starship cargo bay, and once it reaches the surface, it inflates into a pressurized, multi-story structure with enough volume for dedicated work areas, sleeping quarters, and an airlock. ESA ran this design through their concurrent design facility, and the conclusion was, no showstoppers. The physics works, the materials exist, but an inflatable module by itself is still not enough. The fabric walls block the vacuum, but they do not stop radiation. So the next step is burying it. Autonomous robots scoop up regolith from around the landing site and pile it over the inflated structure, layer by layer, until the shell is roughly 1.5 meters thick. At that thickness, the regolith absorbs and scatters the incoming radiation before it ever reaches the crew. Think about that. The radiation shield is not shipped from Earth. It is scooped off the ground. The moon itself becomes the armor. But the long-term vision goes even further. Instead of just dumping loose regolith, what if you could print it into solid structures? That is exactly what ICON is building. Their system is called Project Olympus, a $57 million NASA contract to develop a robotic construction platform for the moon. It uses high-powered lasers to melt lunar regolith directly into a hard, ceramic-like material. No concrete, no binders shipped from Earth, just dust and a laser. ICON has already tested this on Earth using lunar regolith simulants inside a chamber they call the Moonbox. They have even flown a low-gravity experiment on a Blue Origin suborbital flight, called DuneFlow, to study how regolith behaves when it is not being held down by Earth gravity. The goal is landing pads and blast shields first, then walls, then eventually full habitats, all printed from the ground. Now, the honest caveat, and this is important, ICON has tested this on Earth, with simulant, in a controlled lab. Nobody has printed a single structure on the actual moon. The vacuum, the dust, the thermal extremes, from 127 degrees Celsius in direct sunlight to negative 173 in shadow, those conditions have never been tested at full scale. The technology works in a lab. Whether it works on the moon is still an open question. But even if you build the perfect shelter, walls, floor, pressure, radiation shielding, it is still just a box in the dark. Because the moon's night lasts 354 hours. That is almost 15 straight days of total darkness. No sunlight, no solar power, nothing. So the question becomes, what keeps the lights on? If this is the kind of engineering breakdown you have been looking for, not hype, not headlines, just the actual systems behind a moon base, then you have found the right place. Subscribe to the Cosmic Rush. This is where we go deep into the engineering and share what we learn with you. So the obvious first answer to the power question is solar. And on the moon, solar actually works. There is no atmosphere to scatter the light, so panels can be extremely efficient. At the South Pole, there are spots on the crater rims that get sunlight almost continuously. They are called peaks of eternal light. Sounds perfect, right? It is not. Because even at the peaks of eternal light, the sun sits extremely low on the horizon and still dips below the rim periodically. And down on the crater floor, where the water ice is, where the ISRU mining has to happen, there is no sunlight at all. Those are permanently shadowed regions. The exact places you need power the most are the exact places solar cannot reach. And then there is the night, 354 hours of darkness, almost 15 days. Your panels produce 0 watts. Everything that needs electricity, life support, thermal control, communications, lighting, all of it draws from batteries. So let us run the physics. A basic habitat needs roughly 10 kilowatts of electrical power just for life support, thermal regulation, and lighting. An ISRU oxygen extraction plant needs another 20 kilowatts to electrolyze regolith. That is 30 kilowatts minimum, running continuously. Now multiply that by 354 hours of night. You get about 10,600 kilowatt hours of energy storage required. At current lithium-ion battery density, roughly 150 watt-hours per kilogram, that is approximately 70 metric tons of batteries. 70 tons. That is almost an entire Starship payload just for nighttime backup. Just to keep the lights on while you wait for the sun. That is why nuclear power is not optional on the moon. It is structural. Without it, the entire base shuts down every 2 weeks. And NASA already has a head start. In 2018, they successfully tested a small fission reactor called KRUSTY, the kilopower reactor using Stirling technology, at the Nevada National Security Site. It ran continuously for 28 hours at full power, producing about 1 kilowatt of electrical output. The entire reactor was roughly the size of a trash can. The next step is the Fission Surface Power System, a joint NASA and Department of Energy program targeting what they call Lunar Reactor 1. The goal is 20 to 40 kilowatts of continuous electrical power, deployed to the lunar surface by 2030. Here's how it works. At the center sits a compact uranium-235 core. Heat from fission travels outward through heat pipes. No pumps, no moving fluids, just passive conduction. At the ends of those pipes, Stirling converters turn the heat into electricity, and waste heat gets radiated into space through panels on top. The entire unit has almost no moving parts. It runs day and night. It does not care whether the sun is up or not. So the real answer is both. Solar for daytime peak loads when the sun is available. Nuclear for the baseline, 24/7, uninterrupted, regardless of where you are on the surface or what time it is in the lunar cycle. Take away the nuclear reactor, and the moon base has a heartbeat that stops every 15 days. That is not a power grid. That is a death sentence with a schedule. So you have the shelter, you have the power, but both of them depend on something that has to come from the moon itself. Because shipping everything from Earth at over $100,000 per kilogram is not sustainable. At that price, every tank of oxygen, every liter of water, every brick has to come from the ground beneath your feet. And that ground? It is called regolith, and what is hiding inside it might be the most valuable resource in the solar system. Here is the economics that drives everything. Getting 1 kilogram of anything from Earth to the lunar surface costs over $100,000. 1 kilogram. That means a single liter of water on the moon, shipped from Earth, costs more than a luxury car. A ton of oxygen? That is $100 million. At those prices, importing supplies is not a logistics problem. It is a mathematical impossibility for anything permanent. So everything has to come from the regolith. And here's the thing most people do not realize. Regolith is not just dead rock. It is roughly 42 to 46% silicon dioxide by weight, and oxygen makes up almost half of that. So the air you breathe, it is locked inside the ground you are standing on. The engineering challenge is getting it out. The process is called molten regolith electrolysis. You take raw regolith, heat it to roughly 1600 degrees Celsius until it melts, and then pass an electric current through it. The oxygen separates and rises as gas. The leftover is metal-rich slag, iron, aluminum, silicon, which can be used for construction. 1 ton of regolith yields approximately 430 kilograms of oxygen. That is not a concept. The chemistry has been demonstrated on Earth. The question is scaling it up in a vacuum at 1/6 gravity with power from a nuclear reactor the size of a trash can. But oxygen is only half the equation. The other half is water. And this is where the permanently shadowed craters come in. These craters near the South Pole have not seen sunlight in billions of years. NASA's Lunar Reconnaissance Orbiter measured the temperature inside them using an instrument called Diviner, below -240 degrees Celsius. That makes them among the coldest measured places in the entire solar system. And trapped inside that frozen darkness is water ice. In 2009, NASA's LCROSS mission crashed a spent rocket stage into Cabeus crater. The debris plume confirmed it. Water ice is there. Electrolyze that water and you get 2 things: hydrogen for rocket fuel and oxygen for breathing. That means the moon does not just provide shelter material and breathable air. It can potentially produce propellant. A Starship could land, refuel from lunar water, and fly back to Earth orbit without carrying return fuel from Earth. That changes the economics of everything. Now, the obvious objection is, if the ice is really there, why has nobody gone to get it? And that is a fair question. NASA built a rover called Viper specifically to map those ice deposits, to find out exactly how much water is there, how deep it goes, and what form it is in. But in July 2024, they canceled it. Cost overruns and schedule delays. So the rover that was supposed to answer the most important question about lunar resources never flew. And it gets worse. Recent data from ShadowCam, an instrument orbiting the moon on a Korean spacecraft, suggests that the ice may be more patchy and sparse than early estimates predicted. We know it is there. LCROSS proved that. But we do not know how much, how accessible it is, or how hard it will be to extract from rock-hard frozen regolith at -240. That uncertainty is the single biggest variable in the entire moon base equation. So the systems are starting to come together: delivery, shelter, power, resources. But there is one system we have not talked about yet, and it is the one that no amount of engineering can fully solve: the human body. Here is what lunar gravity actually means for your body. On Earth, you weigh, let us say, 70 kilograms. On the moon, your scale reads about 12. Everything feels lighter. Walking feels like bouncing. Lifting equipment feels effortless. And that sounds great for about a week. But your muscles, your heart, your bones, they all calibrate to the load they carry. At 1/6 gravity, that load drops to almost nothing. And over weeks and months, they start to forget what full gravity felt like. On the space station, at 0 gravity, astronauts lose roughly 1 to 2% of their bone density per month. That is the kind of deterioration you would normally see in a 70-year-old. Except these crew members are in their mid-30s. Now, lunar gravity is not 0. It is 1/6, about 1.6 meters per second squared. And indirect evidence suggests it might slow down muscle and bone loss compared to the space station. But here's the problem. The threshold for maintaining musculoskeletal health appears to be around 0.4 G. The moon is at 0.16. That is well below the line. And the honest truth is, nobody knows for certain, because no human being has ever spent more than 3 days on the lunar surface. And then there is the dust. Lunar regolith is nothing like sand on Earth. On Earth, wind and water round off the edges over millions of years. On the moon, there is no erosion. Every grain is razor sharp, jagged, and electrostatically charged. It clings to everything. Suits, visors, airlock seals. Apollo astronauts reported eye irritation and respiratory discomfort after just a few hours of exposure. Long term, the silicate particles behave like a more aggressive form of asbestos. Inhale enough of it, and you are looking at chronic lung inflammation, maybe worse. And one more thing that almost no one talks about, the circadian cycle. The moon's day-night cycle is 29.5 Earth days. That means 15 days of continuous sunlight, followed by almost 15 days of total darkness. Your body's internal clock, the system that regulates sleep, hormone production, immune function, has no idea what to do with that. There is no dawn, no dusk, just a switch between permanent noon and permanent midnight. The machine is engineered for the moon. The human body was not. So now let us stack all 5 systems together, because separately they are just engineering problems. But together, they form something much more important, a loop. Starship delivers the cargo and the initial shelter. That shelter needs power to maintain pressure and temperature. Power, from the nuclear reactor, enables the ISRU mining operation. ISRU produces oxygen, water, and construction material. That construction material expands the shelter, thicker regolith walls, better radiation shielding. Better shielding means the crew can stay longer. Longer stays generate more data on how the human body adapts to 1/6 gravity. And that data feeds directly back into the next Starship delivery. What to send, what to redesign, what to fix. Remove any single system and the loop breaks. No power, no ISRU. No ISRU, no radiation shielding. No shielding, no long-duration crew. No crew, no data. No data, no iteration. That is not a checklist. It is a chain, and every link depends on the one before it. And once this loop starts running, it compounds. Each cycle makes the next one faster, cheaper, and more reliable. That is not a moon base. That is a self-growing system. And that is exactly what Musk means when he says, a city. Now, SpaceX is not the only one building toward the South Pole. Not even close. If you look at the map of planned lunar missions over the next decade, the South Pole is getting crowded. China is arguably the furthest along after SpaceX. Their International Lunar Research Station, built with Russia and over 40 partner nations, is not a concept. It is a funded, phased program. Chang'e 7 arrives this year to survey water ice at the South Pole, with an orbiter, a lander, a rover, and a mini flying probe. Chang'e 8 follows in 2028 to test something critical: 3D printing structural bricks directly from lunar soil. If that works, China will have demonstrated ISRU construction before anyone else lands a habitat module. Their target is a functioning research base by 2035. Japan and India are taking a different approach: mobility. Toyota and JAXA are building the Lunar Cruiser, a pressurized rover the size of 2 minibuses with a 10,000-kilometer range on hydrogen fuel cells. 2 crew members can live inside without spacesuits for up to 30 days. It is essentially a moving habitat. And Japan gets 2 astronaut seats on future Artemis missions in exchange for delivering it. Meanwhile, India, which landed Chandrayaan-3 on the South Pole in 2023 for roughly $75 million, is now building Chandrayaan-4 for a sample return mission in 2027. And they have announced a national goal: Indian astronauts on the moon by 2040. Together, India and Japan are co-developing LUPEX, a joint mission to drill into permanently shadowed craters and directly measure the water ice that Viper was supposed to find. And then there is Blue Origin, NASA's second HLS provider. Their Blue Moon Mark II stands about 16 meters tall, a third the height of Starship. It carries up to 30 tons in cargo mode and supports 4 crew members for up to 30 days on the surface. It is smaller, but it has one advantage. The crew cabin is much closer to the ground. No 35-meter elevator problem. Blue Origin is also running a Pathfinder cargo mission to the moon before the crewed version flies. So SpaceX is not even the only American company building a lunar lander. So let us be honest about the timeline. Everyone has a plan. Musk says a city in under 10 years. NASA says permanent infrastructure by 2036. China says a base by 2035. Japan targets 2032 for the lunar cruiser. India targets 2040 for boots on the ground. And all of them depend on technologies that have been demonstrated in a lab, but never on the moon. The honest assessment is this: the pieces exist. They are more advanced than most people realize, but they have never been assembled together in that environment under those conditions. And the gap between a demonstration and a city is measured in decades, and in the number of things that go wrong along the way. So, is this going to happen? Honestly, parts of it already are. The rocket exists, the nuclear test passed, the 3D printer works in the lab, the water ice has been confirmed from orbit, and 2 separate nations are actively racing to the same patch of frozen ground on the South Pole. But calling it a city is generous. A city has roads. A city has a power grid that does not depend on a single reactor the size of a trash can. A city has air you do not have to mine from rock at 1600 degrees. What SpaceX and NASA and China are building toward right now is not a city. Not yet. It is a construction site on a world with no air, no water on the surface, and no sunrise for 2 weeks at a time. And somehow, that is more impressive than any city. Because every brick, every breath of air, every watt of power on that construction site will have been earned from nothing. That is the blueprint. And it starts with the next Starship that lands. If you want to see how each of these systems is being built, step by step, engineering detail by engineering detail, subscribe and turn on notifications. The next video breaks down one of these systems in full. I will see you there.